right, class, welcome to this edition of Stuff You Should Know. We're going to talk about simplifying radicals today, but specifically square roots. Now, there's a whole bunch of other radicals. I'll talk about that later. Today, we're going to focus on square roots. Now, the background knowledge is this. You got to know your perfect squares. Now, what's a perfect square? It's the product of a number multiplied by itself. So if you've ever seen a multiplication chart, we have like 1 times 1 and 1 times 2, 1 times 3. It's basically all the diagonals. You got to know the perfect squares. Okay, so 1 times 1, 2 times 2, 3 times 3. Know them all. I think going through 15 times itself is a helpful start, but at least being able to recognize these numbers is going to be critical to simplifying your radical expressions. So let's get into what the heck is a radical. So it's a root symbol, and it asks a question. It's an operation. The root symbol asks about a number times itself a certain number of times. So take, for example, the square root. The square root, that symbol, asks a question. What number times itself twice? There's also something called a cube root. Isn't that cool? And the difference between a square root and a cube root is something called the index. The default index is 2. So if you don't see a number there, it's the square root. If you ask anything else, you'll see the number for an index. In the case of a cube root, you'll see the number 3. And that asks a question. What number times itself 3 times? Now there exists a infinite number of roots. So you can also have something like the 10th root. So the same radical symbol, but the index would be 10. And that is asking a question, what number times itself 10 times? So let's see a couple of generic examples, and hopefully that will sink in a little bit. So if you ever see this, you would see, well, this is the square root of 100, and it asks a question. What number times itself twice is 100? So that's what this is asking. The answer, of course, is 10. Also negative 10, but we're not going to worry about that right now. Another example is something like this. We can have a different index. So this is the cube root. So with that, again, it's asking a question. What number times itself 3 times is 27? That's what this is asking. The answer, of course, is 3. So this here, as funny as it is the number 3. So you can count on your fingers with this. You'd say 1, 2, cube root of 27, 4, 5. That's what that is. Okay, it is the number 3. So just like this is asking, how many toes do I have? Square root of 100. That's how many toes I have. It is the number 10. So today we're going to focus only on square roots and see how it is that we simplify them. So what happens then if we have a square root of a number that isn't a perfect square? So what happens if we have a square root of a number that isn't a perfect square? The note is very simple. The note is we must find out if there are any factors of that number that are perfect squares, then we can simplify. I know you're thinking right now, Katz, what in the world are you talking about? Here's an example. So if we have the square root of 8, let's say, hopefully you know that 8 is not a perfect square. You don't recognize 8 from our list of perfect squares, so what in the world do we do with that square root of 8? Well, we have to realize that 8 is a number that is made up of factors, and you know what? One of the factors of 8 is a perfect square. So what we can do is rewrite 8 as 4 times 2, and understand that 4 is a perfect square. Now, we can also rewrite 8 as 2 times 2 times 2, because that's what it is, right? Because 4 is 2 times 2. So there are 2 ways we can approach simplifying this radical. Now, personally, when it comes to square roots, I like to look at it this way because I'm a big fan of perfect squares. Now, what's happening here is a little operation you may know as multiplication. So we can rewrite the square root of 4 times 2 as the square root of 4 times the square root of 2. That is the beauty of multiplication. So when we look at it this way, 4 being a perfect square factor of 8, we can see it as the square root of 4 times the square root of 2. And what is the square root of 4? We know that as 2. What is the square root of 2? We don't know. It's an irrational number, so we can leave it as the square root of 2. So we have 4 times the square root of 2, which is exactly what this is. Reminding you all, once again, what's happening here is multiplication. Now we can also look at it this way. The index here is 2. If you remember, we talked about the index. So the index of that radical is 2. So what we're looking for in the radical symbol are pairs of the same factor. Okay, so we're looking for 2's of the same factor. So if you can see here, we have 1, 2, 3 2's. We have 2 of them. So what we can do is some teachers have taught this, well, we can take that out. Man, I don't like to really call that taking it out until we get into crazy variables, but if we have 2 times 2, and this is the index of 2, a square root, that means 2 is the number that's on the outside of the radical. What's left on the inside is another 2. So either way you look at simplifying radical expressions, the square root of 8 is 2 times the square root of 2. So here's another example. What do we do with the square root of 18? Again, we do not recognize 18 as a perfect square, so how do we handle that? We look for perfect square factors. Hopefully you know that 18 is 9 times 2. Or you can look at it this way, 9 is 3 times 3. Either way, you should be able to see that we can simplify this radical expression as the square root of 9 times the square root of 2. The square root of 9, of course, is 3. The square root of 2 is the square root of 2. So we can look at it that way. Now we can also look at the same thing. Square root, index is 2. Here are my pair of 3's. So the 3 goes on the outside of the radical. The 2 stays on the inside of the radical. Either way, the square root of 18 is 3 times the square root of 2. Remember, this is all multiplication. What happens if we can't tell stuff immediately? Well, we can make our way there. Remember, this is all multiplication that's happening. So the last example we had, we know that this is 3 times the square root of 2. If we can remember that, we can get to wherever we need to be. So what happens with 72? Well, I don't know if you know your times tables very well, but I look at 72, and the first thing that comes to mind is 9 times 8. 9 times 8 to me is 72. So we can look at it that way, or we can realize 72 is 2 times 36, or we can realize that 72, when we use prime factorization, is 3 times 3 times 2 times 2 times 2. Now, where does all this come from? Cats, you're a madman. I know, but 9 is 3 times 3, and 8 is 4 times 2, or 2 times 2 times 2. So we can look at this in many different ways. So what happens if we look at it is 9 times 8? Well, the square root of 9 times the square root of 8. The square root of 9 is 3. Then we have the square root of 8. But what the heck, dude? The square root of 8. We already simplified that. The square root of 8 is 2 times the square root of 2. Remember, this is multiplication here. So we have 3 times 2 times the square root of 2, or 6 times the square root of 2. Okay, so we know we're going to end up with 6 times the square root of 2. If we look at 72 as 36 times 2, the square root of 36 times the square root of 2. Square root of 36, remember, know your perfect squares up there. Okay, so the square root of 36 is 6 times the square root of 2. Or if we look at prime factorization, we're looking for pairs. We have a 3 that goes out and a 2 that goes out. So 3 times 2 is 6. 6 times the square root of 2. Either way you look at what's happening with the square root of 72, it will always be 6 times the square root of 2. That is the simplified radical. Last example, what if we had 4 times the square root of 32? What if we had a number that was already there? So we simplify this the same exact way. What the heck is going on with the square root of 32? So we have 4 times. Now what is 32? 4 times 8. We all know that. What else is 32? Did you know it was 16 times 2? And what else is 32? Well, 2 times 2 times 2 times 2 times 2. It's 2 to the 5th power. That's a neat thing to know. But either way, prime factorization. So no matter how we look at it, we can simplify our radical expression. Knowing that a 4 is already to the outside, now we have the square root of 4 is 2, and then we have the square root of 8. So the square root of 8, we've already simplified before, is 2 root 2. So we have 8 times 2 root 2. 8 times 2 is 16, as you can see here. 8 times 2 is 16. 16 root 2. No matter how we get to there, we're going to have 16 root 2. We have 4 on the outside for this example. 4. Square root of 16 is 4. Square root of 2. 4 times 4, 16 times square root of 2. What about this? 4 is already to the outside. Break a 2. Break another 2. Square root of 2. No matter how, 16 root 2. So that is how we can simplify radical expressions. And again, this is stuff we should already know. And if you've never learned this before, well, now you know. But no matter what, that is simplifying radicals with square roots. Remember, there are other indexes. We can get into other stuff later. So hopefully you enjoyed that. Hopefully that helps. I will see you later.